Let's calculate some molar masses for some compounds. And let's do part A. So we've got this KC₄H₅O₆. And we're going to use the average atomic masses found in the periodic table. I'm using the numbers here from ptable.com. So we've got these numbers on the bottom of the element in each of the boxes on the periodic table. And those are the ones we want to use. So in this chemical formula, we've got potassium, and potassium is 39.098. And in the chemical formula, we just have one of those because we don't have any subscript indicated. It's assumed to be 1. And so we just do that. Now for carbon, it's 12.011. And we multiply that by 4, and so that's going to be 48.011. For hydrogen, we have 1.008, and let's see, we have 5 of those, so that's going to give us 5.04, right, when we do that on our calculator. And now don't worry about units or rounding or anything like that. Just go ahead and type it all in exactly what you get on your calculator, okay? Some of these you can do in your head. This next one I'm not able to. But 15.999 is the mass of one oxygen, and we have 6 of those. So we want to grab our calculators and multiply that by 6. And that gives us 95.994. Okay, so as I mentioned, you don't round these numbers off, you just carry out the operations as I'm doing here. And so the idea here is that if we add all of these up, we'll find out how many grams 1 mole of this cream of tartar molecule is. Okay. And so we grab our calculator and we add up 39.098, we add 48.011, we add 5.04, and this 95 number. Oops, I mistyped something. 39.098, 48.011, 5.04, 95.994. Okay, and I get a grand total of 188.143 grams, and that's for KC₄H₅O₆. Now, if you Google this, you might find this as a result. Might be rounded off a little bit or different, depending on the sig figs and all that, that they're using for their individual periodic table, but you'll have this unit grams per mole. Okay, so it's the same thing. Remember, a fraction can be used to express an equivalency as shown above. So this is the molar mass, and it's always going to have units of grams per mole. Okay, so let's calculate the molar mass of rust. So Fe₂O₃. So we're using the average atomic masses found in the periodic table. I use ptable.com as the source for my atomic weights. So Fe is 55.845, and this formula here has 2 of those. So we want to grab our calculator and compute the total mass for 2 irons. Okay, 111.69. Okay, and then we do the same thing for oxygen. The oxygen has a mass of that, but we have 3 of these in the molecule. So 15.999 times 3 is 47.997. So if you add these up, you will find the mass of 1 mole of Fe₂O₃, and that's equal to So we want to add these. (159.687 grams of Fe₂O₃. Now, if you were to Google this, you might find a different number because of differences in periodic tables and the number of digits. But you might find something like this, grams per mole. Okay, so that's just a different way of expressing an equivalency as a fraction. So that is the molar mass of rust. Okay. Here's problem C. We want to calculate the molar mass of Paxil, an antidepressant. It's composed of carbon, hydrogen, fluorine, nitrogen, and oxygen. Now for this, you want to use the numbers on the periodic table found below. These are the average atomic masses, and these are snippets from ptable.com. That's where I use my periodic table. And so let's go ahead and start. Carbon has a mass of 12.011, and there's 19 of those guys in this formula. So we want to multiply this by 19 to find out the mass of 19 carbons. Okay, so that's 228.209. Next up, we have hydrogen. It's 1.008, and there's 20 of those guys. So we multiply that out on our calculator to find out the total mass of 20 hydrogen atoms. Okay, and then next up is fluorine. We just have one of those. Now we know we just have one because the subscript is not shown. If the subscript is not shown, we assume it to be 1. Okay, so basically we don't do anything to that number. Same thing for nitrogen. We only have one nitrogen. For oxygen, we have 3 of those. So we're going to have to take the average atomic mass of oxygen and multiply it by 3 to find out the mass of 3 oxygen atoms. So punch that in on your calculator. And then what you want to do is add all of these up, okay? So add up all of these numbers. When you add up all of these atoms, you get the chemical formula, basically. And so what we're finding out is the mass of 1 mole of this substance. Okay, so you want to grab your calculator and carefully punch these all in. And we get 329.371, and that's grams of the substance. Okay, so we know how many grams 1 mole is weighing. Now, if you were to Google this, for example, you might find an answer with various numbers of decimal places, but you might see something like this, grams per mole. And grams per mole is just a different way of writing an equivalency, okay, as a fraction. So that is the molar mass of Paxil. Let's do the molar mass of this antiperspirant here. It might be found in your deodorant. So aluminium sulfate. So this molecule or formula is composed of aluminium. I don't make this up. That's how the element is named. Sulfur and oxygen. So These numbers on the bottom of each of the elements in the periodic table are what we want to use. And when you look at the formula, you have to carefully consider the parentheses or the subscripts. So we have Al2 and then the rest. So we have two aluminums. So when you calculate the mass of two of the aluminums, you take the number on the periodic table and you multiply that by 2. And that gives us, let's see here, 53.964. Okay. And then what we need to do is the next element is sulfur. Now remember that each sulfate has one sulfur because the subscript is not shown there, okay? And we have a 3 outside the parentheses. So we have 3 sulfates. Each sulfate has 1. So the way we figure out how many sulfur atoms there are in this formula is, if I can do the math right, multiply the subscripts there, okay? So sulfur is 32.06, and we multiply that by 3, and that gives us 96.18. Next is oxygen. And for this oxygen, you want to be careful. Each sulfate has 4 oxygens, and there's a 3 outside the parentheses. So 4 times 3 is 12. So there's actually 12 oxygen atoms here in this formula. So 15.999 times 12. Okay. And we'll punch this in on our calculator here, is 191.988. All right. And so when you add all this up, you figure out how many grams 1 mole of your substance weighs. So I'll use my calculator here to carefully punch in these numbers. And I urge you to also do so as you follow along with the videos. I get 342.132 grams. And we write the formula Al2SO4 3. Now, if you Googled this substance, it might tell you the molar mass with varying levels of precision out in the decimal places. But it might say 342.132 grams per mole, okay? And remember, that's just a different way of expressing an equivalency. We can express an equivalency as a fraction, but that right there is your molar mass of the aluminium sulfate. Welcome back. I'd like to do the molar mass of magnesium hydroxide, part E, which is found in Mylanta. It's an antacid. Now, we're going to use the average atomic masses for the elements magnesium, oxygen, and hydrogen in the periodic table. It's important that you recognize that magnesium hydroxide with a subscript of a 2 refers to magnesium with 2 hydroxides, okay? So the formula has 1 magnesium in it, okay? And we grab the average atomic mass, and I like to use the average atomic masses from ptable.com. Since there's only 1 magnesium atom, we essentially just don't do anything with it. Now for the oxygen, 1 oxygen weighs, 15.999, okay? Now we have 2 oxygen atoms in this formula because of that subscript of a 2. So we multiply that by 2, and that gives you 31.998 on your calculator. And hydrogen, again, we have a subscript of 2, and we have 2 hydrogens. So each hydrogen is 1.008. We multiply that by 2, and we get 2.016. Now you add all these up and you get the grand total, and this is the mass of 1 mole of your magnesium hydroxide. And so grab your calculator and punch in all of these numbers very carefully, and we get a grand total of 58.319. So that's the mass of 1 mole of our substance, or the molar mass. Now, if you were to use Google to look this number up, you might see the answer reported with various numbers of decimal places in this format: 58.319 grams per mole. Okay, and you can express an equivalency as a fraction, and so that's one way of indicating the molar mass. Okay, so that's the answer. That's the molar mass of magnesium hydroxide. All right, thanks for watching, and please subscribe.